Subscribe to our channel and press the bell icon to never miss any update from Gradeup.
Hello friends, today we are going to go through the JEE Mains 2016 paper, and we'll discuss all the strategies which we could have used while solving these questions. Alright, and we'll also categorize the questions according to their difficulty levels. And let's begin. So here's the portion of first 10 questions, and I've categorized them. So 3 of them were easy, 4 were medium, and again 3 were tough ones. So let's begin. So the first question is from the topic area under the curves. Alright, it's a part of integral calculus. Alright, so we are given that we need to find the area of the region given by this y square greater than equal to 2x. Y square is equal to 2x is a parabola. This represents a circle, and x greater than equal to 0, y greater than equal to 0 represents that it is the first quadrant. Alright, so we have to find the area of this region. I'm really sorry, my drawing is not that good. So let's say these are the 2 points of intersection of the parabola and the circle. So the parabola and the circle will intersect firstly at the origin and secondly at these 2 points. So first of all, we need to find the coordinates of these 2 points. Alright, so we have an equation y square is equal to 2x, and the other equation is x square plus y square is equal to 4x. On solving these 2 equations, on putting the value of y square is equal to 2x, the value of x is equal to either 0 or 2. So this will be 2, 2. So this point is 2, 2. So this is actually just above the center of the circle. Alright, as you can see. So this is just above the center of the circle. So therefore I can say that this portion is becoming a quadrant of a circle. Alright, so this is actually 1/4 of a circle. So what I need to do here is I need to find this shaded region. Alright, why do I need to find this shaded region? Because he is asking us to shade this region y square is greater than equal to 2x, which means the region outside the parabola, and x square plus y square less than equal to 4x means the region inside this circle. So the region inside the circle and outside the parabola is this shaded region. Alright, so now if you see, the area which we need will be equal to 1/4 the area of circle. Why 1/4 area of circle? Because this is becoming a quadrant. Okay, so pay attention to this very carefully. You don't need to integrate anything over here because the integration will become very clumsy. So that's why we are using this shortcut. Minus the area from 0 to 2 for this parabola. So parabola is y square is equal to 2x. So the value of y is equal to root 2x plus minus root 2x. But since we are talking about the first quadrant, we only need to consider this plus 1. So this is minus root 2x. So you just need to substitute the values. The radius of the circle is equal to 2. So you get the area of the circle, which will be equal to pi r square. Alright, and you can easily integrate this one. So the final answer will be D, pi minus 8 by 3. I consider that this question is a bit tough one. Alright, because it needs some concepts from the coordinate geometry as well. Alright, and if you don't apply this thing, this quadrant thing, then the integration will become very difficult, since you'll have to integrate. If you consider a function from here, you'll have to integrate this quantity, root 4x minus x square dx. Alright, from 0 to 2, and this integration can become a little tough. Alright, so let's see the next question. So the next question is from the chapter functions, and this thing here is known as a functional identity. So these are functional identities. Fx plus 2 times f1 upon x is equal to 3x. And we are given a set that fx is equal to f of minus x. So we need to find out how many elements belong to this set S. Alright. So first let's see this functional identity. Let's solve this functional identity first. Okay. So so this is a very important trick which you need to know, that whenever you have fx and f1 upon x in one functional identity, in the same functional identity, what you need to do is, once you put x over here, the next time you have to replace x with 1 upon x. Now if you replace x with 1 upon x, the first equation, which was fx plus 2 times f1 upon x is equal to 3x. If you replace x by 1 upon x, you get f of 1 upon x plus 2 times fx is equal to 3 upon x. So this is what we get. Alright. So these are the two equations. If you simultaneously solve these two equations, you can easily find the value of fx. So multiply this equation, this full equation, by 2. Alright. So you get the value of fx, which will be equal to 2 upon x minus x. So you can simply see that the value of fx will be 2 upon x minus x. Now he is asking you how many elements belong to this set, fx is equal to f of minus x. So we have 2 upon x minus x will be equal to minus 2 upon x plus x. Alright. And if you solve this equation, you get x square is equal to 2. X is equal to plus minus root 2. Alright. So I replaced x with minus x over here, and I equated these two, and finally I get x is equal to plus minus root 2. So it contains exactly 2 elements. Alright. So this is also an easy question if you know the concept. So let's move to the next question, which is from the topic indefinite integration. So this is a medium level question. So let's see how we proceed for this question. Now first of all, see, you have 2 times x to the power 12 plus 5 times x to the power 9. So integration here is a bit tough. Just like this, what I need to do is I need to pull out a power of x from the denominator. So this is a very important method which you need to revise if you don't know already. Pull out power of x from denominator, and most likely this is actually the maximum power. So you need to pull out the power x to the power 5 from the denominator. So if you pull out x to the power 5 from the denominator, it becomes x to the power 15. So it becomes 2x to the power 12 plus 5x to the power 9 upon x to the power 15 upon 1 plus 1 upon x square plus 1 upon x to the power 5 cube. So this is what we get, which is actually 2 upon x cube plus 5 upon x to the power 6 dx, 1 plus x square power 5 x cube. So what I did here is I took out x to the power 15 and I divided the numerator by this power. So if you substitute this term in the bracket as t, okay, if this whole thing is t, this will become minus dt. Okay, see this very carefully. So if I have t is equal to 1 plus 1 upon x square plus 1 upon x to the power 5, I integrate this, dt becomes minus 2 upon x cube minus 5 upon x to the power 6 dx. Alright, so this numerator will become minus dt. So we get integration of minus dt upon t cube. Now it becomes a very simple question. So the integration here will be equal to minus, so this is t to the power minus 3, it becomes t to the power minus 2 upon minus 2. Alright, so I get the answer t to the power minus 2 plus c. Alright, and then substitute the value of t here and you will get the answer. Okay, so the answer to this question will be D part. The next question is from the topic Applications of Derivatives. Okay, so let's go to the question first. So function is given fx is equal to log 2 minus sin x with a modulus sign. Okay, and then gx is equal to f of fx. Okay, this is a composite function. Okay, so let's first write down gx. So gx will be equal to log 2 minus sine of fx. Now if you see very carefully with a modulus sign, okay, so if you see very carefully here, so fx is log 2 minus sine x. So if I have f of fx, this x will be replaced by fx. Okay, so I will get fx in both these sides. And then if you again put the value of fx here, you get log 2 minus sine of log 2 minus sine x. Alright, so this is the value of gx which we finally get. Okay, and if you see this log 2 minus sine x, okay, the value of log 2 is almost 0.30, and if you need to find the differentiability of this function at x is equal to 0, you need not worry about the sin x. Okay, this sin x will be very small than this log 2, so that's why we can remove this modulus from here, because this will be always a positive quantity, since log 2 will always be greater than the value of sine which is in the vicinity of x is equal to 0. So that's why I'm removing modulus over here. I'm just differentiating this function. So g dash x becomes minus cos log 2 minus sine x multiplied by minus cos x. And if you want to find the value at x is equal to 0, you get g dash 0 is equal to minus of cos of log 2, since sine 0 will be 0, and this is multiplied by minus 1. So you get the answer cos of log 2. This will be the final answer. So this was a comparatively medium question, moderate level question, because you just need to know this fact, because most of the people were confused with this negative and positive sign, but there's nothing to worry about, because here this fx, all right, this the value of x is in the vicinity of x is equal to 0. That's why you don't need to worry. So you just need to make some correction over here, that this term will not be here. This is unnecessary. Sorry, I forgot to exclude this in the beginning. So g dash 0 will be equal to cos of log 2. So let's move on to the next question. So the next one is from the topic circles. All right, so center of those circles which touch the circle. So one circle is given, and we have to find the center of those circles which touch this circle externally, and they also touch the x-axis. So first of all, let's see what is the characteristic of the circles which touch the x-axis. Now we know that the circles which touch the x-axis, let's say if they have the center h comma k, their y-coordinate will be the value of the radius. So I can take it as modulus of k. Alright, why am I taking it modulus of k? Let's say the center is 2 comma minus 3. Then the radius cannot be equal to minus 3. It cannot be equal to exact value of k. It will be equal to the absolute value of k. So the radius here will be equal to 3. Alright. And then you are given another circle which has a center 4 comma 4, and the radius is, let's calculate the radius, 4 square plus 4 square minus of minus 4, which is plus 4. So 32 plus 4 is 36, 6. So radius here is equal to 6. So if two circles touch externally, we know the condition that the distance between the centers is equal to the sum of the radius. So C1 C2 is equal to R1 plus R2. So if you calculate the distance between the centers, that will be square root h minus 4 square plus k minus 4 square, and this will be equal to modulus k plus the radius, which is equal to 6. And if you square both sides, you get h square plus k square minus 8h minus 8k plus 32 k square plus 36 plus 12k. So this is simple calculation. So k square and k square cancel out. Alright, so this is modulus k, sorry, since we have modulus k over here. So k square cancel out, I get 4 over here, and finally I will get an equation looking like this. So if I complete the whole square over here by adding 16, I will get 12k, 12 times modulus k plus 8k plus 20. And you can see that this is actually equation of the form x square is equal to 4ay, which is the equation for a parabola. So the answer to this question will be a parabola. So we needed to find the locus of the center of those circles which touch this circle as well as this touch the x-axis. So the next question is sum of all the real values of so here will be x. Sum of all the real values of x satisfying the equation x square minus 5x plus 5 to the power x square minus 4x. So this is plus 4x, x square plus 4x minus 60 is equal to 0. So I consider that this was one of the very tricky questions of 2016. So why do I consider that this is a tricky question? Because there will be 3 cases. So most of the students have included 2 cases, but they forgot to include the third case, okay, which is very crucial. So let's see how will we proceed to this question. So let's say we have a to the power b. Okay, so a to the power b is equal to 1. What are the different possibilities with which we can make this value is equal to 1? With which we can make this quantity is equal to 1. The first possibility is that b is equal to 0. So any number to the power 0 is always equal to 1. So this is the case 1. Alright. Case 2 is that a is equal to 1. The 1 to the power any number, that is always equal to 1. And the case 3, which most of the people have not included, is that a is equal to minus 1. So let's say the value of a is equal to minus 1. So what power can I have so that I get the result is equal to 1? So this b should be equal to an even number. So if b is an even number, we can say that a to the power b will be equal to 1. So if b is equal to 0, first let's see this case. So x square plus 4x minus 60 is equal to 0. So you get 2 values of x. The first one is minus 10 and the second one is 6. I am not solving the quadratic equation altogether. So these are the 2 values which we'll get. The second case is a is equal to 1. So this quantity inside the brackets will be equal to 1. So x square minus 5x plus 5 is equal to 1. You get x square minus 5x plus 4 is equal to 1. You get 2 values of x, 1 and 4. Alright. So if you add these all quantities, you get the sum is equal to 1. Okay, which is not given, which indicates that this is not the exhaustive amount of cases. Okay, there will be a third case also, which is x square minus 5x plus 5 is equal to minus 1. So if you see this part, so you get x square minus 5x plus 6 is equal to 0. So x minus 2 into x minus 3 is equal to 0. So you get 2 values of x, 2 and 3. Okay, but both these values may or may not satisfy this equation, because if a is equal to 1, b should be equal to an even number. So the value of b is x square plus 4x minus 60. If you put x is equal to 2, it satisfies, it is an even number. If you put x is equal to 3, it does not satisfy, because you will get 9 over here and both of these are even numbers, so therefore this is not an even number. So the exhaustive set of values will be 1, 2, 4, 6 and minus 10. And if you add all these, this cancel out, you get the sum is equal to 3. Alright, so I consider that this was one of the toughest question of JEE 2016 mains paper. So the next question is from the topic sequences and series. Okay. So second, fifth and ninth term of a non-constant AP, okay, so the common difference is not equal to 0, are in GP. So let's write down the second, fifth and ninth term first. So second term will be a plus d, fifth term is a plus 4d, and the ninth term is a plus 8d. So these three terms are in GP. So if you write the equation, the condition for the GP, a plus 4d square should be equal to a plus d multiplied by a plus 8d. Alright, because if you have three numbers in GP, sorry, so three numbers are in GP, you get b square is equal to AC. So that's what we applied over here. So on solving, you will get the final result as AD is equal to 8D square. And if you solve it further, simplify it, you get D times A minus 8D is equal to 0. So either D is equal to 0 or A is equal to 8D. So get two possibilities over here, that D can be equal to 0 or A is equal to 8D. Since D is not equal to 0, therefore the value of A here will be equal to 8D. So if you put the value of A is equal to 8D, you get the second term as 9D, this term as 12D, and this is 16D. Alright, it is also given that these terms are in GP and the common ratio can be easily calculated by dividing these two. So 12D upon 9D, the common ratio will be equal to 4 upon 3. Alright, so let's move on to the next question, which is from the topic hyperbola. The eccentricity of a hyperbola whose length of lattice rectum is equal to 8. So length of lattice rectum is given. We know that the length of lattice rectum is equal to 2b square upon a, both in the case of hyperbola and ellipse. You don't need to confuse yourself. And the length of the conjugate axis is equal to half the distance between the foci. So length of the conjugate axis is equal to 2b, and this is equal to half the distance between the two foci. So the distance between the two foci is actually equal to 2AE, so the half the distance will be equal to A. Sorry. So if you square this equation, you get 4b square is equal to a square e square. And we also know a relation between b, a and e, which is b square is equal to a square times e square minus 1. So this is in the case of hyperbola, and b square is equal to a square 1 minus e square in the case of ellipse. So we need this quantity, we need to use this formula. So we get 4 times a square e square minus 1 is equal to a square e square. And if you calculate the value of e from here, you will see that e square is equal to 4 by 3. Therefore e is equal to 2 by root 3. So it was a very simple question. Actually this was not useful at all in this question. Okay, this was unnecessary thing, but if you start using this to solve this whole eccentricity, then the question might become a bit tough. Okay, because the equations might be, become a little clumsy, and it might be a bit time consuming. So this is a shortcut method to solve this question. Let's move on to the next one. So the next question is from the topic binomial theorem. So number of terms in this expansion. So you have an expansion of the form 1 plus a plus b to the power n. Alright, so you have 3 terms over here. Alright, so this is not a binomial theorem first of all, but you can convert it into binomial theorem if you take 2 terms on one side and 1 term in the next side. But just note down that the total number of terms over here will be equal to n plus 2c2. Alright, so by using this concept that the total number of terms of this trinomial expansion with the power n is equal to n plus 2c2. Since the total number of terms are given as 28, we can equate this as 28 we get the value of n. So if you solve this n plus 2c2, you get n plus 2 into n plus 1 upon 2 is equal to 28. So n plus 2 into n plus 1 is equal to 56. So get the value of n from here, which is equal to 6. Alright, so you need to find the sum of all the coefficients of the term. So sum of all the coefficients can be found by putting x is equal to 1. So this is always the case. Put all the variables is equal to 1 and finally get the answer. So 1 minus 2 plus 4 to the power 6. So the answer will be equal to 3 to the power 6, which is equal to 729. And finally, the last question, the Boolean expression P. So these are the two symbols. So this symbol is for and the other one is for or. So sorry. So let's start solving this question. So first of all, I am going to solve these two parts. So P and negation of Q. So this symbol represents negation Q, not Q, or Q. So if you solve this bracket, you will get somewhat like this. So this is P or Q and negation Q or Q, and the rest of the part is same. Alright, so this is a distributive property. You can distribute this or to both of these. Alright, since this is outside the bracket, you can take this or Q over to both sides. So P or Q and negation Q or Q. Okay, so what do we mean by negation Q or Q? So let's say this is Q and the outside part is negation Q. So Q or negation Q gives you the whole universal set. Okay, in the language of sets, this will give you the whole universal set. In the language of Boolean expression, this quantity will always be true. Okay, since if you are choosing something from either Q or not Q, it is always true. Okay, it is always present in either of these two scenarios. So you get P or Q and the truth. Okay, or you can say this is a universal set. And further we have or negation P and Q. Okay, so this is P or Q and T. So we have to take the intersection of these two. So if you take the intersection of, let's say this is P or Q part and this is a total part. So if you were to take the intersection of these two parts, it will come out as P or Q. Alright, because the intersection of this circle with the total set will be this circle itself. So you get P or Q or negation P and Q. Okay, this is what we are getting finally. And then I can distribute this symbol. Alright, so this whole bracket can be distributed to both of these. So how are we going to distribute this to both of these, negation P and Q in the second bracket? We take P or Q, okay, or negation P. This is in the first bracket. Since we have a symbol of and over here, the symbol of and persists, and here we have P or Q or Q. Alright, so this is what we are getting here. So I just distributed this term P or Q to both of these. Okay, so first I take its or definition with negation P, and then I take its or with this Q, and in between these two I have an AND statement. Okay, So if you see this very carefully, you have P or not P. So this is again similar to this one, Q or not Q. In this case we have P or not P. So this will actually give you total part. Okay, this will always be true. So this is T or Q, and you have P or Q or Q. So there's no need of writing Q 2 times. So if he is giving you P or Q, so this actually means P or Q. Okay, you don't have to repeat the same set twice, okay, because it is meaningless. I can write it 5 times, but it will have the same meaning. Okay, so total or Q. So now I have to see the union of total and Q. So the union of total and Q will be equal to total itself. The intersection of total and Q will be Q, but the union of total and Q will be equal to total itself. So you get total and P or Q. Now you have to see the intersection of this P or Q with total. Therefore this will be equal to P or Q. Okay. So this question from Boolean Algebra, I consider that this was a tough question because here you have to use lots of laws according to this and OR statements, and also you need to know about this negation statement. Another way of solving this question is from truth tables. I don't recommend that way because in that case you have to check all the 4 options. Okay, that will be a bit time consuming. If you learn all the methods to solve such statements, it is rather simpler. Okay, so that's all. So this was the first part of JEE Mains 2016 solution. So stay tuned for the next 2 parts. Thank you.